Okay everybody, I'm making this video. I'm sorry if the sound quality isn't as good, but I couldn't get the headphones to work. So this is the third time I've made this video for you. Anyways, with that said, we're going to go ahead and start with this complex fraction. Now, a complex fraction is just a fraction where you have a fraction in the numerator and a fraction in the denominator. And all it really is just a vertical way of writing a division problem. So we're going to go ahead and we're going to rewrite it horizontally because it looks a little bit better that way. Now, it's very tempting to just try to take this right here, flip it all over, and multiply it. You can't do that because the numerator and denominator here are broken. And you need to fix them. You need to fix them into one fraction each. So what we have to do is add these two terms together. So we're going to give both the x and the y a 1 as their denominator. So coming over here to the numerator, we'll multiply 1 by y. That's y. So that's my denominator. This term right here already has y as its denominator. So we're just going to put the 1 in the numerator. Now this x over here has to have y as its denominator. So we're going to multiply in the numerator and the denominator by y and get an xy in my numerator. And we're going to do the same thing over here. Common denominator is 1 times x, or x. The 1 is good already, but we have to multiply the y by x over x. So we have xy in our numerator right here. Then we're going to go ahead and now we can divide because our numerator and denominator are both all fixed up. So we have x plus y over 1, or over y, times, and we're going to go ahead and take the reciprocal of this second term, xy plus 1, and you're going to notice that you have an xy plus 1 both in the numerator and in the denominator. So you can cancel those out, those divide out to be 1, and you're left with x over y. Now the next problem that you wanted to see was a rather complicated rational equation. So here it is, number 16, and I need a bigger piece of paper on which to do this one. So I'm going to go ahead and write it out over here. So we've got x plus 1 over 3x minus 1 plus 2x plus 1 over 3x minus 2 equals negative 1. Now what most people don't like about this is the denominators. And I don't blame you. This looks like a really complicated problem, so it'd be really, really nice if we could just get rid of those denominators. And we can do that. But before we do that, let's take a look at what we know our answer cannot be. If we set this denominator equal to 0 and solve, we get 1/3, which means that if we put 1/3 into this denominator, for x, we're going to get 0. We don't want that. We're going to do the same thing over here and get 2/3. So our answers cannot be 1/3 or 2/3. We need to keep that in mind and check it out at the end of the problem. But let's get to the solution portion. What we're going to do to get rid of these denominators is multiply every single term in the equation by this denominator, 3x minus 1 times 3x minus 2. It's going to look big and ugly at first, but you're going to find it's going to look a whole lot better once those denominators are gone. So let's go ahead and do that. We have our 3x minus 1, 3x minus 2, and we're going to multiply it by every single term. Now this is going to take a minute to write out. And now we're ready to start getting rid of some of those denominators. So if you notice with this first one, we have a factor of 3x minus 1 both in the numerator and in the denominator of this fraction. That means that they cancel out. They divide out to be 1. And I'm just left with 3x minus 2 times x plus 1. And then in the next term, we have a 3x minus 2 both in the numerator and the denominator. those cancel out, and I'm left 3x minus 1 times 2x plus 1. And then on the other side of the equation, yes, we do have to do this on the other side of the equation as well. We have 3x minus 1 times 3x minus 2. Now we're ready to multiply. So we'll just do a little foiling here and get 3x squared, then positive 3x, negative 2x, negative 2 times 1. So 6x squared, a positive 3x, a negative 2x, a negative 1. And then on this side, I'm going to multiply these and at the same time multiply through by negative 1. So we have a negative 9x squared. So we have a negative 6, a negative 3. So that's going to, once I get the negative 1 in there, that'll give me a positive 9. Then 2 times negative 1, negative 2. Now, let's go ahead and combine the like terms on the left-hand side. So we'll get 9x squared plus 2x minus 3 is equal to negative 9x squared plus 9x minus 2. So all we're looking at here is a quadratic equation. So we need to set one of these sides equal to 0. So let's go ahead and cancel everything off the right-hand side. I think that's going to be a little bit easier. It's going to keep our leading coefficient positive. And then what we're going to have is 18x squared minus 7x minus 1 equals 0. So let's see if we can factor this thing. So we're going to try it out. We're going to put our x here, multiply a times c, and then we have our b here is negative 7. So what we're looking for is, do we have factors of negative 18 that add up to negative 7? And the good news is we do. We have negative 9 and 2. That means this guy is factorable. So let's go ahead and put our parentheses out. Now, this right here, this 1, there's only one way to multiply two integers together and get a 1. That's 1 times 1. And we've already decided that we want a 9 and a 2. Now, don't worry about me not putting a negative there, because remember, the leading coefficient is still positive. So I want a positive 9 and a positive 2. But how do I get that negative 9? I make the 1 that I'm going to multiply it by negative. And then that means this one has to be positive, so I can get a negative 1 up here. Now I've got my factors. I can set each one equal to 0 and solve and get x equals negative 1/9, x equals 1/2, and then check back up at the top to make sure neither one of those is the one that I don't want. Well, I didn't want 1/3 or 2/3. Neither one of these is 1/3 or 2/3, so they're both valid solutions. The next thing you wanted me to look at was special right triangles. So we have two special right triangles, our 30, 60, 90, and our 45, 45, 90, which is isosceles. Now the ratios in our 30, 60, 90 go like this. The side opposite the 30 is the smallest side, that's S. The side opposite the hypotenuse is 2S, twice that side. And then the side opposite the 60 is S times the square root of 3. So let's see how to use this. Let's say that I have a right triangle, 30, 60, 90, and I know that the side opposite the 60 is 6. So the first thing I'm going to do is write in my ratios, S, 2S, and S root 3. And what I'm trying to do is find S, because once I find S, it'll be very easy to figure out what the other two sides are. So to find S, all I have to do is isolate the S down here by dividing by the square root of 3. So S is equal to 6 over square root of 3. Rationalize the denominator. Get 6 root 3 over 3, which is 2 root 3. So S is equal to 2 root 3. Well, guess what, guys? This side is S. This is 2 root 3. And then all I have to do to find the hypotenuse is replace that s over here with a 2 root 3. So the hypotenuse is 4 root 3, and that's all I have to do to find these sides. Now our 45, 45, 90 has s and s, because the sides are the same length, their angles are 45 and 45, and then the hypotenuse is s root 2. And I do the 45, 45, 90 the same way, except I use those ratios in the triangle. Now the last thing that you wanted me to talk about was right triangle trig. So let's see if we can get a good handle on this. So let's say we have a right triangle. And I'm going to go ahead and label the angles. Now side B is opposite angle B, side A is opposite angle B, and side C is opposite angle C. And when we do trig, we're looking at the sides from the perspective of one of those acute angles. So let's say we're looking at our triangle from the vantage point of angle A. That means that side A is your opposite side, side B is your adjacent side, and then of course side C is your hypotenuse because it's opposite the right angle. So we're going to label these. Now the sine of the angle is opposite over hypotenuse. The cosine of the angle is adjacent over hypotenuse. And the tangent of the angle is opposite over adjacent. That's where SOHCAHTOA came from. S-O-H, C-A-H, and T-O-A. So how do we use this? So let's say that we know that angle A is 40 degrees and that side C is like 8 centimeters. Well, I can figure out the other two sides of that triangle and angle B. I have to use trig to find the sides, but to find angle B, all I have to do is subtract 40 from 90, because remember, the acute angles of a right triangle add up to 90 degrees. So 90 minus 40 is 50. So there is my angle B. Now, to find side A, I'm standing up here at angle A. I need to find side A, which is the opposite, and I know what the hypotenuse is. So I'm working with opposite and hypotenuse, that is sine. So the sine of 40 degrees is equal to A over 8. And then to solve for A, all I have to do is multiply both sides by 8. The 8's cancel out over here. And put this into my calculator, which of course should be in degree mode, and then all I have to do is put in 8 times the sine of 40, and my answer is approximately 5.14. To find side B, I want to find the adjacent side. I have the hypotenuse, that is cosine. So the cosine of 40 degrees is equal to B over 8. And we're going to solve exactly the same way and just put 8 times the cosine of 40 into the calculator and get approximately 6.13. Now, let's say that you have sides and you're trying to find an angle. So let's say that you know that this side right here is 5 and this side right here is 7. And you want to find the measure of the two acute angles. So I'm going to start with this one right here. I'm going to call this one angle A. So the side 5 is opposite angle A. Side 7 is adjacent. So I want to use the tangent to find the size of the angle. So I'm going to write down that the tangent of angle A is equal to 5 over 7, opposite over adjacent. Now when I'm finding the measures of angles, I have to use the inverse tangent. So inverse tangent is located right here on your calculator, right here. And notice how in my calculator it's colored blue. So that means I have to use the second key in order to access that. So second tangent, and then I just put in the ratio 5 divided by 7, enter, and I'm told that my angle is approximately 35.54 degrees. And then to find the other acute angle, just take 90 minus answer and get 54.46 degrees. And that's all there is to it. Guys, study hard for your quiz. I'll see you next week. And I'm sure everybody's going to do great.